Before beginning this section, you should review the Introduction to Hypothesis Testing, the Introduction to Hypothesis Testing about Means, and the Hypothesis Testing about Means when sigma is known sections. In this section, we will discuss hypothesis testing about proportions. In general, a hypothesis test about the value of a population proportion P will take on one of the three forms listed on this slide. We use P0 to denote the hypothesized value of the population proportion. In the first case, our null hypothesis is P is greater than or equal to P0, and our alternative is P is less than P0. In the second case, our null hypothesis is P is less than or equal to P0, and our alternative is P is greater than P0. And in our third case, our null hypothesis is P equals P0, and our alternative hypothesis is P does not equal P0. Recall from the central limit theorems for proportions that we can assume that P is normally distributed provided the conditions listed here in red are met. Therefore, in order for us to use the test statistic or rejection rules outlined on this slide, we must ensure that the required conditions here are met for our specific problem. Our hypotheses are the same as listed on the previous slide. Our test statistic is the z-score for our p-bar value, and our rejection rules have a similar structure to the rejection rules listed in our hypotheses about means section. Recall that our standard deviation of P is equal to the square root of P times 1 minus P divided by N. Since we have already had a lot of practice conducting hypothesis tests, let's dive right into doing a hypothesis test example for proportions. For a Christmas and New Year's week, the National Safety Council estimated that 500 people would be killed and 25,000 injured on the nation's roads. The NSC claimed that 50% of the accidents would be caused by drunk driving. A sample of 120 accidents showed that 67 were caused by drunk driving. Use the data to test the NSC's claim with alpha equals 0.05. For this example, since their claim did not indicate that more or less than 50% of the accidents would be caused by drunk driving, we should set up equality hypothesis test. Our null hypothesis is our proportion is equal to 0.5 for 50%, and our alternative hypothesis is the proportion does not equal 0.5. In step 2, we should go out and collect a sample of n items and use that sample in order to analyze our hypotheses. We should state our sample size as well as our level of significance which is 0.01 for this problem. In step 3, we should go out and research the appropriate test statistic and rejection rule to use for this scenario. We should state our null hypothesis, which is p equals 0.05, and our sample size, which is n equals 120. For proportion problems, we don't know information about the entire population. Since this is a hypothesis test about a proportion, we can use one of the set of test statistic and rejection rule listed on this slide, provided this required condition is actually met for this problem. For our problem, since 67 out of the 120 accidents were caused by drunk driving, our p-bar value is equal to 67 over 120, which equals 0.56. So we have to verify that n, which is 120, times p, which is 0.56, is greater than 5. And if you compute this in your calculator, you'll see that this value is greater than 5. And also, you should verify that n, which is 120, times 1 minus p, which is 0.44, because that's 1 minus 0.56. 120 times 0.44 is also greater than 5. Since the required conditions are met, we can use the test statistic and rejection rule that matches our null hypothesis. The last box contains a null hypothesis that is similar to ours. Our null hypothesis is p equals 0.5. Therefore, we could write down the test statistic and the rejection rule from this box. In step 4, we list our test statistic. And in step 5, we list our rejection rule. For alpha equals 0.05, we should write our z alpha over 2 critical value, which is 1.96. In step 6, we compute our test statistic. Our standard deviation of p-value is equal to the square root of p0 times 1 minus p0 divided by n. For our problem, p0 is the value listed in our hypotheses. Therefore, the standard deviation of p is equal to the square root of 0.5 times 1 minus 0.5 divided by our n value, which is 120. The standard deviation of p is equal to 0.045644. Our z test statistic is p bar, which is 0.56 for this problem, minus p0, which is the value listed in our hypotheses, which is 0.5 for this problem, divided by the standard deviation of p. If you compute our test statistic, you should obtain 1.278. In step 7, we should use the value from our test statistic and our rejection rule in order to decide whether we should reject our null hypothesis. We were told to reject our null hypothesis if the absolute value of z is greater than or equal to 1.96. Since our test statistic value, 1.278, is not greater than or equal to 1.96, we should not reject H0. Since we are unable to reject H0, this means that we do not have enough evidence to prove that HA is true. So for this problem, we don't have enough evidence to prove that the proportion of accidents caused by drunk driving during the Christmas and New Year's week does not equal 50%. Example 10. A county school board member believes that most county residents are in favor of eliminating the school diversity assignment policy. In order to test this claim, he hired a research firm to collect data and see if they could find sufficient evidence to prove his claim that the majority, or P is greater than 50%, of voters favor eliminating this policy. The research firm randomly contacted 500 county registered voters and asked their preference. His research revealed that 270 of the 500 residents favored eliminating this policy. Conduct a hypothesis test to see if you could find sufficient evidence to prove the board member's claim. Use an alpha equals 0.05 level of significance. In step 1, we should state our hypotheses. Since we are trying to prove that more than 50% of residents favor eliminating this policy, we should state the claim that we are trying to prove as our alternative hypothesis. Therefore, our alternative hypothesis is P is greater than or equal to 50%, or 0.5. Our null hypothesis is P is less than 50%, or 0.5. In step 2, we should go out and collect sample data in order to test our hypotheses. We should state our sample size, which is N equals 500, and our level of significance, alpha, equals 0.05. In step 3, we should go and research the appropriate test statistic and rejection rule for our scenario. We should note our null hypothesis, which is P is less than 0.5, and our sample size, which is N equals 500. As previously mentioned, for a hypothesis test about proportions, information about the entire population is not normally given. Since we are conducting a hypothesis test about a population proportion, this slide contains the test statistic and rejection rule for our problem. This second box contains a null hypothesis that is similar to ours. Our null hypothesis is P is less than 0.5. Therefore, the test statistic and rejection rule listed in this box is appropriate for our problem. However, we cannot use this test statistic or rejection rule until we verify that the required condition is met for our problem. Since 270 out of 500 of the residents say that they favor eliminating this policy, our p-bar value is 270 divided by 500, which equals 0.54. Therefore, N times P, or 500, times 0.54 is indeed greater than 5. And also N times 1 minus P, or 500 times 0.46, is also greater than 5. Since the conditions have been met, in step 4, we can list our test statistic And in step 5, we can list our rejection rule. For an alpha value of 0.05, we should follow the steps for computing Z alpha in order to obtain a Z alpha value of 1.645. In step 6, we compute our test statistic. We plug our value of P0 into the formula for the standard deviation of P, and P0 is the value in our hypotheses, which is 0.5. If we do this, we obtain the standard deviation value of 0.045644. Therefore, in computing our test statistic, we plug in our p-bar value, 270 divided by 500, which equals 0.54, minus our P0 value, the value listed in our hypotheses, divided by the standard deviation of P. And we should obtain a test statistic value of 0.876. In step 7, we're supposed to apply our rejection rule and the value of our test statistic in order to determine whether we should reject H0. Our rejection rule told us to reject H0 if Z is greater than or equal to 1.645. Since our test statistic value was equal to 0.876, and this value is not greater than or equal to 1.645, we should not reject H0. Recall that since we cannot reject H0, this means that we do not have enough information to prove that the alternative is true. Therefore, we do not have enough evidence to prove that most county residents are in favor of eliminating the school diversity assignment policy.